Hello learners, welcome to the next lecture on hybrid electric vehicle. In the previous lecture, we learned about the parallel hybrid electric vehicle, its configuration, operation, working modes, power coupling mechanism, and along with a discussion on commercialized vehicle model. In this lecture, we delve on series parallel hybrid electric vehicle. By name itself, it gives the understanding that is combination of a series hybrid electric vehicle and parallel hybrid electric vehicle. Again, it creates a curiosity in a mind, and it is bit interesting like how this combination will take place. And the second configuration that we will also cover in this lecture is a complex hybrid electric vehicle. All the vehicle configuration that we have gone through till now are either front wheel drive or rear wheel drive. However, the complex hybrid electric vehicle are all wheel drives. So, we will see how exactly the component architecture and entire mechanism of the complex hybrid electric system works in upcoming time. So, a series parallel hybrid electric vehicle is an advanced type of hybrid electric vehicle that combines the feature of both series and parallel hybrid system. This configuration offers greater flexibility and efficiency in the vehicle operation, optimizing the use of both internal combustion engine, or in another term that we are using is mechanical propulsion system and electric propulsion system, to improve fuel economy and further to reduce the emission. As this fuel economy and reduced emissions are the two terms which are coming repeatedly, but it is bit important to understand here that this is the two prime objective for which this different vehicle configuration have been introduced, just to enhance the efficiency and to minimize the emission. Apart from this too, the performance and the driving experience are also important aspect, but these two aspects are given more emphasis while designing the different combination and configuration of hybrid electric vehicle. So, this is the architecture of a series parallel hybrid electric vehicle. If you see it carefully, definitely you will get a good glimpse of a series hybrid electric vehicle and parallel hybrid electric vehicle. So, as I mentioned earlier, it is nothing but a combination of the series and parallel hybrid electric vehicle. So, as you can see in this architecture, the electric propulsion system and mechanical propulsion systems are connected or combined in a manner that both the propulsion system can deliver their power to the vehicle in parallel mode, and both the configuration or both the propulsion system can come in a series to drive the wheels of the vehicle or to deliver the tractive efforts to the wheels of the vehicle. So, in this series parallel hybrid electric vehicle, it is to extract the advantages of both the combination series and parallel. Whenever it is required, you drive the vehicle in a parallel configuration, and as per the need and requirement you can bring them in a series combination to get a better performance and efficiency. So, if you see the component, again the total component of a series parallel component is very much similar to the component that we have used in a series hybrid electric vehicle and parallel hybrid electric vehicle. As you can see, it has a battery, power converter, electric motor, electric generator, IC engine, fuel tank, and mechanical coupling. So, a series parallel hybrid electric vehicle is an advanced type of hybrid electric vehicle that combines both the technology or both the world of series and parallel vehicle. This configuration offers greater flexibility in operation, either you go for series operation or parallel operation. So, the key aspect to this series parallel hybrid electric vehicle are: the series parallel hybrid electric vehicle combines again the benefit of both the vehicle. This can be achieved by incorporating an additional mechanical link as seen in series hybrid and an extra generator as found in a parallel hybrid. This dual approach enhances the flexibility and efficiency of the vehicle. It can operate as a electric intensive mode or IC engine intensive mode. The series parallel hybrid electric vehicle is categorized into two primary configuration based on this dominance, either it is a electrically dominated or it is a mechanically dominated. In electric intensive hybrid in electric intensive mode of operation, the electric motor is the primary power source dominating the vehicle's propulsion, whereas in IC engine intensive mode, the internal combustion engine takes the precedence, providing the main driving force. The size of key component depends on which configuration is adopted. If it is a electric intensive mode, the size of the battery and motor should dominate, and if it is a IC engine intensive mode, certainly the size of internal combustion engine should dominate over the electric propulsion system. So, if you talk about the operating modes of a series parallel hybrid electric vehicle, it includes starting, normal driving, acceleration, deceleration, braking, battery charging and different driving scenario. These modes are consistent across both electric intensive and IC engine intensive configuration, with the primary difference occurring in the normal driving mode. In this mode, efforts are focused on operating the IC engine at its most efficient point, optimizing fuel economy and performance. In the engine intensive setup, the IC engine alone propel the vehicle. However, in the electric intensive setup, the IC engine assists the electric motor, allowing for more dynamic and efficient use of both the power sources. Another aspect is the component sizing and efficiency. As discussed earlier, the design and sizing of the hybrid electric vehicles component are crucial for maximizing the efficiency. In electric intensive configuration, larger electric motor and batteries are needed, whereas in IC engine intensive configuration, more powerful IC engines are required. Regardless of the configuration, optimizing the component size ensures the vehicle operates efficiently across various driving scenarios. If you see the advantages of series parallel hybrid electric vehicle, then it leverages the strength of both series and parallel system. This hybridization provides improved fuel efficiency, enhanced performance and greater operational flexibility. However, the inclusion of additional electrical and mechanical components such as generator and planetary gear arrangement for power coupling coming from both the power plant increases the system's complexity, weight and cost. So, since you are combining both the vehicular technology, so it naturally brings the advantage of hybrid electric vehicle with it as well as the disadvantages associated to them. However, this combination complements the disadvantages associated with them to the greater extent, so that better performance, better vehicle performance can be achieved. If we talk about the operating mode and power flow management, then as we have discussed, the series parallel hybrid electric vehicle works in the two mode, IC engine dominated mode and electric motor dominated mode. So, the operating modes are categorized under each of these categories. So, let's first discuss the IC engine dominated series parallel hybrid electric vehicle and its different operating mode. In this, the mode 1, that is at starting, the battery alone provides the necessary power to propel the vehicle and the internal combustion engine remains in off state. Again here, one of the important point that is to be taken care is the connection link. The single line represents the hydraulic connections, the double line with white fill represents the mechanical connections, and the double line filled with the black arrow, double line with arrow and having a black filling represents the electrical connection. In mode 2, during full throttle or acceleration, both IC engine and electric motor shares the required traction power so that the desired acceleration is achieved. In mode 3, during normal driving, the required traction power is provided by the IC engine only and the electric motor remains in the off state. In mode 4, during the normal braking deceleration, the electric motor acts as a generator and it helps in recovering the energy during deceleration braking by means of regenerative braking, and that recovered energy is fed back to the battery for further charging. In mode 5, to charge the battery during the driving or during driving the internal combustion during normal driving, the internal combustion engine delivers the required traction power and also charges the battery. In this mode, the electric motor again acts as a generator. In mode 6, when the vehicle is at standstill or when the vehicle is not in operation, the internal combustion engine can deliver power to charge the battery via electric motor and power converter. So, this is the 6 different operating mode associated with the operation of series parallel hybrid electric vehicle in IC engine dominated mode. Let us see the different operating modes of series parallel hybrid electric vehicle in electric motor dominated mode, or in another term you can call it a electric propulsion system dominated mode. This mechanical propulsion system and electric propulsion system, IC engine and electric motor respectively are used interchangeably at a different place on different occasions. So, do not get confused. Electric propulsion system, electric motor, mechanical propulsion system, IC engine. So, in electric propulsion system dominated mode, in mode 1 during starting, the electric motor provides the traction power and the internal combustion engine remains the off state. In mode 2, during full throttle, both internal combustion engine and electric motor provides the traction power, very much to IC engine. This particular mode is very much similar to the IC engine dominated mode. In mode 3, during normal driving, the IC engine and electric motor both are capable to provide traction power. So, based on the IC engine's operating zone and based on the battery's SOC, either of the mode can be taken to drive the vehicle. In mode 4, during braking deceleration or regeneration, the electric motor acts as a generator and the energy is recovered to charge the battery. In mode 5, to charge the battery during driving, the IC engine delivers the required traction power and also it delivers power to the battery. In this case, the electric motor acts as a generator. This particular scenario is made to place the IC internal combustion engine to its optimum operating zone. So, whatever excess power coming out of the IC engine after meeting the requirements of the tractive power, the excessive power is directed or routed to charge the battery via electric motor. In mode 6, when the vehicle is at standstill or not in a operation, again the internal combustion engine can deliver power to charge the battery via electric motor, which is acting as a generator. So, these are the different operating modes in mechanical propulsion dominated condition and electric propulsion dominated condition. Now, let us see the different advantages and disadvantages associated with the series parallel hybrid electric vehicle. Again, the advantages are very much similar to hybrid electric vehicle. It has dual power source, optimized fuel efficiency, automatic power distribution, versatile reduced emissions and energy regeneration. If we talk about the disadvantages or issue associated with the series parallel hybrid electric vehicle, then it is a limited electric only range. However, it can be tinkered based on the electric propulsion intensive mode, or based on the placing the electric propulsion intensive mode higher side in comparison to the mechanical propulsion intensive mode. Complexities and cost, as series parallel and series parallel, all three modes are coming together. So, certainly it will bring control, it will bring more complexities in control mechanism, high upfront cost, it will also have decent maintenance requirement, and again since we are using a internal combustion engine, so it has a certain degree of dependency on the petrol and diesels. These are some of the commercialized electric vehicle based on the series parallel configuration of hybrid electric vehicle, or series parallel based on the series parallel hybrid electric vehicle configuration: Toyota Highlander, Ford Fusion, Hyundai Sonata and Kia Optima. So, series parallel hybrid electric vehicle represents a sophisticated blend of series and parallel hybrid technology, offering a versatile and efficient solution for modern transportation needs. By combining the best aspect of both hybrid system, series parallel hybrid electric vehicle optimizes the use of internal combustion engine and electric propulsion system to enhance overall fuel economy, emission reductions and provide seamless driving experience to the user. However, the series parallel hybrid electric vehicle are not without drawbacks. Their complex design can lead to a higher cost and potentially greater maintenance need compared to simpler hybrid architecture. Additionally, while some automakers are developing series parallel hybrid electric vehicle, there are currently no commercially available models. Those models that I have shown are some of the models that they have used this architecture, but I hardly see any series parallel configuration based vehicle models are presently available for sale. So, overall series parallel hybrid electric vehicle holds promise for a more versatile and efficient future of hybrid transportation. Continued research and development effort will be crucial in addressing the cost and complexities challenges to bring series parallel hybrid electric vehicle to market and broaden consumer options. That is all about related to the series parallel hybrid electric vehicle. So, let us discuss the another configuration of the hybrid electric vehicle, which is a complex hybrid electric vehicle. The world of hybrid electric vehicle is about to get a whole lot of more interesting. While series and parallel hybrids have dominated the market, a new breed is emerging, and that is complex hybrid vehicle. This innovative technology takes hybrid electric vehicle to next level, offering a captivating blend of efficiency, power and adaptability. So, let us prepare to delve into the fascinating world of complex hybrid vehicle. We will explore the unique feature that sets them apart, uncover the potential benefits for drivers and the environments, and discuss the exciting possibilities this technology holds for the future of transportation. One of the interesting aspects associated with the complex hybrid electric vehicle that I have mentioned in introduction, that all the vehicle segment that we have discussed in hybrid electric vehicle, they are either a rear wheel drive or a front wheel drive. However, the complex hybrid electric vehicle is to be considered as all wheel drive vehicle configuration. So, this is the architecture of complex hybrid electric vehicle. Before discussing the architecture of complex hybrid electric vehicle, if you see the component, again it is very much similar to the component of hybrid electric vehicle. So, I will not go on the discussion of the component. Let us directly discuss the architecture and modes of operation of a complex hybrid electric vehicle. So, if you see the complex hybrid electric vehicle architecture, all the components are somehow or other interlinked with all the wheels. It means the IC engine vehicle has a capability to propel the front wheel as well as it has a capability to propel the rear wheel, At the same time, the electric propulsion system has the capability to propel the front wheel. At the same time, it has a capability to propel the rear wheel. The mechanism and the coupling and the arrangement have been made in a such a way so that the electrical or mechanical power can be delivered to all four wheels either individually or simultaneously. The different aspects associated with the complex hybrid electric vehicles are dual axle propulsion. Unlike previous configuration that focus on a single axle propulsion for either the front or rear wheels, the complex hybrid configuration is designed for dual axle propulsion. This means both front and rear wheels can propel the vehicle, providing greater versatility and tractive force. Decoupled axles. In the complex hybrid architecture, the front and rear wheel axles are decoupled and mechanically independent from each other. This independent operation allows for greater flexibility in how power is delivered to each axle, enhancing the vehicle's performance and handling. It has bidirectional flow. The complex hybrid configuration has ability to facilitate bidirectional power flow through the electric generator, unlike the series parallel configuration which only supports unidirectional power flow. This capability allows for more efficient energy management and usage within the vehicle powertrain. It has flexible propulsion option because of the decoupling and all-wheel drive. The complex hybrid configuration offers the ability to drive the vehicle using either electric propulsion system, hybrid propulsion system, or combination of both. This flexibility allows for optimized performance based on driving conditions and enhances the vehicle's efficiency and reliability. The front wheels can be driven by a hybrid system, while the rear wheels are driven by an electric system or vice versa. It has multiple operating modes and gear arrangement, uses the planetary gear arrangement to couple the internal combustion engine and electric propulsion system and axles together. This setup allows for independent control of the front and rear wheels, resulting in smooth operation and enhanced vehicle reliability. When the front wheels are powered by the hybrid system, all wheels are driven, whereas the starting with the front wheel driven by the electric system only propel the front wheels only. So, in that way either you can have IC engine start, you can have a hybrid start, or you can have a pure electric propulsion system based starting. In most of the scenario and in most of the cases, electric propulsion system based starting is preferred. However, I am again repeating it, this electric propulsion system based starting can be applied to either side of the wheel, but most of the time it is taken with the front wheels. It has enhanced efficiency, but at the same time increases the control complexities. Regenerative braking is applied to all four wheels in the complex hybrid configuration, significantly improving the system efficiency and fuel economy because it has fairly good amount of energy recovering during regeneration, as energy from all four wheels can be recovered. However, this increased efficiency comes at the cost of added complexities and higher expenses in the vehicle's design and maintenance, since it has multiple modes of operations either in front wheel drive, rear wheel drives, combining both. So selecting and picking a specific operating modes involves a good amount of complexities, and that needs to be taken care properly. Overall, the complex hybrid configuration represents a significant advancement in hybrid vehicle technology, offering enhanced flexibility, efficiency and performance through its innovative dual axle propulsion system and independent control capabilities. Let us discuss the different operating mode of a complex hybrid configurations. It has two categories in which these operating modes are applied: front hybrid, rear electric, or front electric and rear hybrid. In both the case, it has 6 different modes of operation, which are more or less very much identical. So let us discuss the first one, that is front hybrid and rear electric. So in mode 1, during starting, the required traction power is delivered by the electric propulsion system and the mechanical propulsion system remains in a off state. In mode 2, during full throttle acceleration, both mechanical propulsion system and electric propulsion system delivers power to the front wheel, and the second electric motor which is available delivers power to the rear wheel. So in this mode, all wheel gets power and they brings the vehicle into good motion. In mode 3, during normal driving, the IC engine delivers power to propel the front wheel and it drives the first electric motor as a generator to charge the battery. In mode 4, during driving at light load, first electric motor delivers the required traction power to the front wheel, the second electric motor and the IC engine remains in off state. In a fifth mode, during braking deceleration, both the front and rear wheel electric motor act as a generator to simultaneously charge the battery and hence ensures the recovery of good amount of energy and further its utilization for charging of on-board battery. In mode 6, a unique operating mode of complex hybrid system comes, that is axial balancing. In this mode, if the front wheel slips, the front electric motor works as a generator to absorb the change of IC engine power. Through the battery, this power difference is then used to drive the rear wheels to achieve the axial balancing. This sixth mode is equally applicable for other combination, that is front electric and rear hybrid, and hence that is being not discussed here. So one important part that I have mentioned here is the axial balancing. This is something new to the discussion of hybrid electric vehicle. It becomes very crucial for having a good understanding on axial balancing. Therefore, let us set some light into the key aspect of axial balancing in complex hybrid electric vehicle. So axial balancing in hybrid electric vehicle refers to the management and distribution of power between the front and rear axle to ensure optimal performance, efficiency and on-road stability of the vehicle. In complex hybrid configuration, where both axle can be independently powered by different propulsion system, balancing becomes crucial for maintaining vehicle dynamics and efficiency. In independent propulsion system, some hybrid configuration, the front axle might be powered by the hybrid system and the rear axle might be powered by an electric motor. This setup allows for various combination of power delivery to optimize its combination. The vehicle's control system continuously monitors driving condition and distributes power between the front and rear axle. This distribution can vary based on factors such as speed, traction load. For example, during acceleration, power might be sent to both axles for improved traction, while during steady state cruising, one axle might be predominantly used to enhance efficiency while other axle remains on free wheel. In traction control, axial balancing is critical for maintaining traction and stability, especially in adverse driving condition like wet or icy roads. By adjusting the power delivered to each axle, the vehicle can prevent wheel slip and ensure better handling and control. In case of regenerative braking, both the front and rear axle can capture and convert kinetic energy into electrical energy, which is stored in the battery. Efficient axle balancing ensures that regenerative braking is applied optimally across both axles, maximizing energy recovery and improving overall efficiency. Hybrid vehicles often comes with various driving modes like eco, sports, off-road or traffic, hill climbing, city driving, highway cruising and all, that alters the power distribution strategy. For instance, in eco mode, the vehicle might prioritize electric only propulsion and balance power to maximize fuel efficiency, while in sports mode, it might deliver more power to both axle for enhanced power. Another aspect to axle balancing is the adaptive system. The complex hybrid electric vehicle must equipped with the adaptive system that learn from the driver's habit and road condition to optimize the axle balancing dynamically. The system use sensors and algorithm to continuously adjust power distribution, ensuring the best possible combination of efficiency, performance, safety and tailpipe emission. So, axle balancing in a hybrid electric vehicle is a complex but crucial aspect that significantly impact the vehicle's efficiency and performance. Hybrid electric vehicle can optimize their operation to meet various driving conditions and requirement, providing a superior driving experience while contributing to the environmental sustainability. As hybrid technology continues to advance, axle balancing system will become even more sophisticated, further enhancing the benefits of hybrid electric vehicle. These are some of the commercially available electric vehicle which utilizes the complex architecture. The first one is the Toyota all-wheel drive, Lexus RX 450h, BMW i and Volvo XC90 T8. In hybrid electric vehicle, the onboard battery is mostly charged by internal combustion engine only. However, here in BWM i8 and Volvo XC90, both are having the possibility and feature in which these two vehicles battery can be plugged in to power outlet, outside power outlet, and that brings them to a category known as plug-in hybrid electric vehicle. The discussion on the plug-in hybrid electric vehicle will take place in week 4's lecture. So, that is all for series parallel hybrid electric vehicle and parallel hybrid electric vehicle. So, let us have some quick quiz to review our understanding on these two hybrid electric vehicle configuration. So, the first quiz that we can take is, in a series parallel hybrid system, how do the internal combustion engine and electric motor works together? Among given options, if you closely examine and recall the content covered in the lecture, then you can certainly be able to answer this, and the answer is the IC engine can either charge the battery or drive the wheels directly. Another question that we can take is, which of the following is benefit of series parallel hybrid electric vehicle? One of the best benefit that a series parallel hybrid electric vehicle gives is the flexibility in power management for optimal efficiency. Keeping another quiz related to the complex hybrid electric vehicle, what is the major challenge associated with the complex hybrid electric vehicle? So, when you examine the different aspects associated to the complex hybrid electric vehicle, one can come to know that the major challenge associated with the complex hybrid electric vehicle is higher initial cost due to advanced technology, component and control complexities. Another question is, which of the following vehicle is an example of series parallel hybrid electric vehicle? Sort of the mentioned different category we have recently discussed, that the Toyota all-wheel drive vehicle is the example of complex hybrid electric vehicle architecture. So, that is all for this lecture. I hope this lecture have helped the learner to improve their understanding on series parallel hybrid electric vehicle and complex hybrid electric vehicle. Thank you. Thank you so much.